Hello folks, we are starting with the exercise 3.4 part 1 and we have finished the bunch of formulae that we had studied earlier. We have taken up problems based on that. Now here we are going to take up this part where they ask us to find the principal and general solution for the following equations. They give us some equations and they ask us to find the principal and the general solution. That's a new concept totally. But before we actually go into solving that and finding what is the principal solution, for finding what is the general solution, there are some aids which will help us to get the general solution. Like for example, whenever sin x equal to 0, if you get an equation of that kind, then you can find a general equation and the general solution will be x equal to n pi. Suppose if you have cos x equal to 0, then also you can find a general solution and the general solution will be x equal to 2n plus 1 times pi by 2. Now this, as you do for sine, you can do for tan also. Tan x equal to 0, you will get the same solution like in the case of sine. Now these were the cases when they become equal to 0. There are cases when the sin x value becomes equal to sine of some other value. Like for example, sin x equal to sin y, if you get, then also you can predict a general solution. And how is that? X equal to n pi plus minus 1 raised to n times y. You can predict a solution like that. Cos x equal to cos y, you can predict x equal to 2n pi plus or minus y. Tan x equal to tan y is x equal to n pi plus y. It's enough if you know so many, then we can duplicate. Like for example, cosec will be the same like sine, sec will be the same like tan, and cot will be the same like tan. So therefore, that way, so we can like duplicate. So therefore, no need to study everything. If you study these three basic things, and we are able to, same is the case there also, you are able to duplicate on the basis of what you have for these three ratios. So with this much may look little weird because, but it's okay. As we keep solving the problems, we'll get to know more about this. We have to do two things. We have to find out principal solution. We have to find out general solution. Now, once you find out principal solution, general solution is easy because of this. But we have to find out the principal solution. Your base about the angles, the quadrants, the ratio, which quadrant what, which quadrant every ratio, every trigonometric ratio, how, in what type it is, all that has to be absolutely clear. Only then we are able to do this comfortably. We are able to enjoy the work only then. So we will gradually see how we can do it. They have given us that tan x equal to root 3. Given that tan x equal to root 3, what is x? That is the question. You have to find out x in a particular way. That is why they say principal solution and they say general solution. Generally also, there may be many solutions actually to this. So the principal one at the in the first phase of its rotation, we find that out. That is what is called as principal solution. General solution is this arm can rotate many times and you can have n number of solutions. So that is going to be the general solution. So when we see it, it will be clear right away. They have given us tan x equal to root 3. You should get it in this form. Only then we are able to predict the solution. So let us see how. If tan x equal to root 3, this means that tan x equal to tan pi by 3. Is there anything wrong? Nothing wrong. Why? Because root 3 is tan 60 actually. Yeah, root 3 is tan 60 and because it is tan 60, instead of writing root 3, I have written tan 60. Tan 60 is pi by 3. There's no harm, we can write it like this, right? Why we have written it like this? Because we want it to fall into this category. Tan x equal to tan something, then only we are able to predict the solution. So that is why we are falling into that part. Here what we will do is, see, this is one thing, that tan x equal to tan pi by 3. What you will do is, because this trigonometric ratio is positive, just look, tan in which all quadrants is positive. Tan ratio is positive in the first quadrant and in the third quadrant. Therefore, this can be principal solution, means you should have 2. So therefore, it can be this root 3, tan's value is root 3. Always if you have a certain value will happen twice in the quadrants, you know, in two places you will have root 3. So one place we found it as tan pi by 3 because you know it ready made. It will happen elsewhere also, and that is in the third quadrant. Now in the third quadrant we have learned that every angle is of what type? Are we remembering that in the third quadrant every angle is of the type either pi plus theta or 3 pi by 2 minus theta. Now we generally avoid pi by 2 and 3 pi by 2 because there is a ratio change. So that is why we will always try to take things with pi and 2 pi, so that the working becomes very comfortable. So it is in this quadrant everything is of the type pi plus theta. So therefore at pi plus pi by 3 also it will be root 3. Just take that as the crux of the matter. How did we get this? We first traced out that quadrant where tan is positive. So we got the quadrant number 3. Then we looked at the quadrant number 3 and looked at its general form. What is its general form? Pi plus theta. And what is the theta? Theta is nothing but this thing. So we got pi plus pi by 3. That's how you'll get the angle now. Pi plus pi by 3, when you work it out, how does it come? Pi plus pi by 3, here it's 1 into 3 into 3. So 3 plus pi by 3, 4 pi by 3. So what have we got in net effect? Thus, what have we got? We have got tan x equal to tan pi by 3 and tan x equal to tan 4 pi by 3. This is how you get the principal solution. Therefore, the principal solution is x equal to pi by 3 comma 4 pi by 3. That is about the principal solution. Now you have to find out the general solution. It's very easy because you have this ready reckoner. Just pick it up from there and get it. You can write, since tan x equal to smallest angle you take, tan pi by 3. We'll look out for this. You can get the general solution right away without any hassle. Therefore, x equal to n pi, y is this angle. So, n pi plus pi by 3 is the general solution. Is the general solution. That's all. Right. So, in the entire working, what is a little tricky is this part. If you're able to get this part, then everything is very, very easy. It just flows like water, right? So, this is about it. That is our problem number 1. Now, problem number 2 also on the same lines, you have to find out the principal solution and then you have to get the general solution. Here it is sec x equal to 2. I'll just check the question if it's correct. Yes, it is sec x equal to 2. Correct. Sec x equal to 2, positive value only. Now, like before, sec x equal to 2, where does this happen first? In the first quadrant, at what point does it happen? It happens at 60. That means it happens at pi by 3. So, one value you got. One more value will come. And where it will come? Where sec is positive. Where is sec positive? In the fourth quadrant. And in the fourth quadrant, how is the angle? The angle is of the type 2 pi minus theta. So what we have seen that yet another value which is positive will happen in the fourth quadrant, and in the fourth quadrant every angle is of the type 2 pi minus theta. So what we will do, we will write sec x is equal to sec 2 pi, and what is that theta that we get from here? It's a hint, all these are hints, but when we work it out it will come right, that when you work out this angle it will come to sec, the sec value will come to 2, right? Now let's work this out. How much will this come to? Into 3, 6 pi minus pi, 5 pi by 3. 5 pi by 3. Okay, so this is how you get a hint. Now what has happened? Thus, you have got sec x in the first case becoming pi by 3, and you have got sec x in the second case becoming 5 pi by 3. So that becomes the general solution. So therefore, not general solution, the principal solution. Therefore, the principal solution is x equal to pi by 3 and 5 pi by 3. So these are the principal solutions. General solution is easy. I said sec behaves same like cos. So just catch hold of this cos thing and get the answer. See, here what had happened is we had written sec x, take the smaller value, it is sec pi by 3. So what will happen? Because sec x equal to sec pi by 3, we take this x becomes equal to 2n pi plus or minus y, which is pi by 3 for us. So what happens to this? This is the general solution. Is the general solution. Just that much, right? So this is our question number 1 and 2. Further questions we will take it up in the next video. Thank you.